A warm welcome to all the viewers. In this session, we are going to discuss about the second approach which is used for bibliometric analysis, that is science mapping. In the session number 4, I discussed the metrics involved in performance analysis, and in this session we are going to particularly focus upon the metrics which are given to us by Biblioshiny application of RStudio in science mapping. So what is science mapping? How do we do it? How does it help us? What does it tell us? So I'm going to answer all these questions. Just stay tuned and keep watching. An approach used to visualize the intellectual structure of a research field, which includes the relationships between authors, relationships between documents, and the relationships between the concepts. If you might recall, in performance analysis, we gauge the performance of authors, institutions, countries, basically on the number of publications. But in science mapping, we try to find out the patterns, the networks, the associations, which helps to identify the dominant themes, the gaps, current trends, evolution of a topic, and research collaborations. This is achieved through citation analysis. So when we talk about citation analysis, it is of two types: co-citation analysis and bibliographic coupling. By co-citation analysis, I mean if there are two articles of two different authors and they have been cited by another source, both of them have been cited by another article, in that case, those two will be having a relationship, and we will try to find out what is the relationship between them, why they are so important to be cited together by a third article. So this is known as co-citation. Inversely, bibliographic coupling means when two authors in their individual paper cite the same references, then these two are known as coupled, bibliographic coupling. Then we talk about keywords co-occurrence. How often the same keywords occur in different articles, and the co-authorships, collaborations between authors, collaboration between institutions, and the collaboration between countries. It can be a single country publication, it can be a multiple country publication. So that helps us to identify the themes and trends in the current topic. Now, why I have highlighted bibliographic coupling over here is because it is better to conduct bibliographic coupling through VOS Viewer rather than Bibliometric's Biblioshiny app. Because if you want to conduct bibliographic coupling, you need to know the coding, because it can be done in Bibliometrics and is not available to be done in the graphical interface which is known as Biblioshiny. So in case you are not good with coding, in the upcoming video I'll show you how to do bibliographic coupling in VOS Viewer. For now, let us see what is available to us in Biblioshiny application. Before we go into Biblioshiny application, let us see what are the metrics used over here. First is citation analysis that identifies influential publications by analyzing their citation counts. I've already told you co-citation analysis. Groups publications that are frequently cited together to reveal foundational themes and seminal works. Bibliographic coupling identifies similar research themes by analyzing publications that share common references. It's especially useful for revealing the current developments in the field. Then we have the co-word analysis, which analyzes the relationships between keywords in a text to identify the trends in research topics. And co-authorship analysis, which maps the collaboration networks by analyzing author affiliations, their institutions, and countries to show geographic and institutional distribution of research. So here am I in my R Studio. The Biblioshiny application needs to be open now. So first I need to go into Bibliometrics library. For that I type library, round bracket open, and Bibliometrics, and press enter. After this, command gets executed. I need to start Biblioshiny. So here is the code for Biblioshiny. I just copy it and paste it like this. So that will take me to the Biblioshiny web interface, which runs locally on your system. There is no need of internet to run it. So once you have installed it, it will directly run on the local web interface of your computer without the internet. So now I'll import the data, the same data which I used for the session number 4, wherein I showed you the performance analysis. Now that's a bibliometrics file which has already been converted by us. You might like to go back and check on the previous sessions to know more. Now I load bibliometrics file, browse, and this is the file, combined file in XLS format. I click open and then I click start. So again we are there with the same data, 697 documents. We have already covered the part on performance analysis in the previous video. In this I'll show you what is concerned with science mapping. So for science mapping, you see, we can check on the conceptual structure, the social structure, right? So these are the two things which we can check. We can check on clustering, clustering by coupling, and this documents part we have already covered in performance analysis. So I'll directly go to the conceptual structure. In conceptual structure, you see the first one is co-occurrence network. So I click on co-occurrence network, and there I need to press this play button, and it will show me the co-occurrence network. Now you see, this is the co-occurrence network wherein I can easily spot 3 different clusters. One is red, one is blue, and one is green. It is based upon all keywords included in my database. I can further change the field by going into this thing. In case this was just Web of Science data, then it is recommended to use Keywords Plus. Keywords Plus are automatically generated keywords through the references of the articles which are present over here, but that is given to us by Web of Science data when we download it from Web of Science. It is not given to us by Scopus. Since this is a merged data having Web of Science and Scopus records, we'll take in all keywords. In case you want to see in the titles of the databases, you want to see single words, then you select unigram. You want to select bigrams, then there will be two words joined together, just like academic writing. It is formed of two different words, right? Artificial intelligence, two different words are there. So if I just say academic, or if I just say writing, that is a unigram. So let me show you how does unigram look like. And I click play. After selecting unigram in titles, that means it will search the titles of all those articles which are there in my database and find out the single most occurring words, most co-occurring words, and try to build a network on that. So now you see academic is the biggest circle over here, which tells us that this is the word most frequently found in the titles of the database which I have uploaded. And the second one is writing, third is AI. So you see they are all connected, and they are connected with different dots as well. Then if I want to see the density, so this is the same density which is shown to us by a heat map. If I want to see the table, in this I can see the table. So it mentions cluster number 1. What are the words in cluster number 1? See, it is just showing 10 rows for now. If I increase it, show all, then you will see that cluster, there are 3 clusters. So these are the words in cluster 1. Then here you have cluster 2, and then you have cluster 3, right? I go to degree plot. So this is the degree plot, wherein on the y-axis you have cumulative degree, and on the x-axis you have the node. Next, let us check out the thematic map. So I go to thematic map and press the play button. Now this is the thematic map in which you see niche themes, emerging or declining themes, motor themes, and basic themes. On the y-axis you have density, that is development degree, and on the x-axis you have relevance degree, or also known as centrality, right? So you see here the basic themes are academic writing, chat GPT, and generative AI. Academic writing, 238 times it's occurring. Then emerging themes, I don't have any in emerging themes. And on the crossover of emerging and niche themes, I have artificial intelligence with occurrence of 236. That's the maximum. So this is the thematic evolution. It is based upon author's keywords and the number of cutting points 1. What is this number of cutting points? Say for an instance, I have a data of belonging to 2016 till 2025, and I see through the review of those sources, those articles, that there was a trend changing somewhere around 2019 in the publications. There was a change or something new was coming in. At that time, I need to put in a cutting point at 2019 so as to see two segments. One is 2016 to 2019 and the other is 2020 to 2025. So after thematic evolution, we go to factorial approach. Under the conceptual structure, we have network approach and we have factorial approach, right? We have already discussed about network approach. Now let us see the factorial analysis in factorial approach. I click on that and then I press the play button and I'll get the results you see here. So this is a word map. You also have a topic dendrogram over here, wherein you can easily spot that there are three main clusters being formed by looking at this dendrogram, and words by cluster. So after seeing the factorial analysis, I can go to social structure, wherein I can see the collaboration network. I need to press on play button. So this is the collaboration network. Again, something which is quite useful. Field is authors. I can also do it on the basis of institutions and countries. So I can find out the collaboration network between authors, institution and countries by using this different fields over here. So on the basis of authors, this is it. And the bigger the size of the node, that means the stronger is the contribution of that author. So the stronger contribution, and it is connected to more people, the collaboration this author is having is higher. So you see over here for Liu, if I see, it's the biggest round red circle which I see over here. So see how many collaborations does he have. He has the maximum number of collaborations with other authors. That's why this circle is bigger in size, and the distance it exhibits with different nodes, different authors, is also large. So if I want to see what is the strength of this collaboration network, I just go to the table, and you see over here Liu, betweenness is 16.167, closeness 0.045, and it is on the top, right? Then if I see density, in density also I see Liu is in the center in dark red color. If I go to degree plot, so again you see Liu is on degree 1. That means this is the author which has maximum collaboration with other people, right? Countries collaboration world map. If I go to countries collaboration world map, I get to see the collaboration between different countries. So you see here, the darker the color, the better the collaboration that country exhibits with other countries. So you see over here country USA, and then you have China, right? So country collaboration between China and US, this country. So you see that there is a big amount of collaboration in publishing articles between China and USA. And you can even take this out, export it out, and put it in a Word document through this one. You can export plot as PNG. You can also add it to the report by clicking on this plus button. Once you have gathered all these things, you can go to the report. This is the report, and whatever you have added will come in this report, which will be exported onto your system from this BiblioShiny application as an Excel file, and then you don't need to come back again and again to look in for different things. That single Excel file will help you to find out whatever analysis you want, and you have added it to that file.